So elastic potential energy is going to be the stored energy that comes from a change in the position of the particles or the compression or stretch of a rubber band or a spring. And so what that means is that how far, so if this was my spring, that's normal, right? And then I stretch it and I pull it this way, and now my spring is stretched. So the position of the particles are, so this guy was very much that far apart from the end. And now it is this far apart from the end. Okay, so then there's a change in position of the particles. So that's what it would look like if it was stretched. And then maybe if it was compressed together versus how it was normal, right? So normally maybe they're a little bit more spread out. And so now they're all squished together versus how they were initially. And so this one got shorter, okay? And this one got longer. So the longer one we'll say is a stretch. And when it gets smushed together like this, we'll say it's a compression. So then there's a change in the particles. And the symbol that we are going to be using for elastic potential energy is a capital E with a subscript of a lowercase e. Now, in the two scenarios below, we're going to talk about the compression and stretch. So here we have one that is this long, and this one is only stretched that long. So the one that is stretched not as far is going to have less potential energy. So the one that stores more EE will have a bigger compression or bigger stretch. Okay, so bigger compression or bigger stretch. A will have more because it has a bigger stretch. Or you can also say that there is a greater change in position of particles. So the particles of the rubber band here has changed more dramatically than the particles of the rubber band here. Now, in our slinky, which one has more elastic potential energy? And so we have a slinky that's just kind of open and relaxed. And then we have a spring here, or like they can't both be A. So we have a spring here that has been compressed, right? So this is, we'll say that one is compressed. And this one is kind of relaxed. Okay, so in its relaxed state, it's going to have a greater distance away from each other. And the compressed, you have to put a little bit more energy to smush it together, right? So remember, anything that's smushed or stretched is going to have more elastic potential energy. So we're going to say B has more potential energy because it has a greater change in the position of particles. Okay, in other words, it has a greater compression than A. And so now below, what you're going to do is create your own scenario below. So make sure that you're talking about something that is compressing or stretching. And that would be elastic potential energy.